So hello Year 11 and welcome to the fifth lesson in the series of key skills that you need to have gained from GCSE in order to be able to apply them to A-level. And one that I know is going to be very, very unpopular, and that is you do need to know your chemical tests that were mostly, if you did AQA, in the C8 topic. And I know that many people, particular AGS, don't like learning facts. They don't see the point in learning facts. But unfortunately, as you will see today, the A-level course builds on those facts in order to expand them and gives you a whole new set. So if you come into A-level not knowing your GCSE ones, you've got twice the work to do as someone who's already got those sorted. So for those of you unlucky enough to have been taught by me, you will have heard me sing this to you. I'm not going to inflict that on you today. You can imagine this being sung to the tune of the 12 Days of Christmas. But I'm going to go through the tests of C8 that you should already know. Number 1, on the first day of lessons, my teacher made me state a test for a metal sulfate. How do you test for sulfates? If you wish to play along, pause the video and have a think. If you don't know, you need to add, as it says here, barium chloride solution. And what will you see? Well, if there's a sulfate, you will see a white precipitate being formed. However, there's a few things that can give a false positive, and therefore we need to add an acid. So it's not just barium chloride solution, it is actually acidified barium chloride solution. We would usually use hydrochloric acid. The one thing we would not use, for very obvious reasons, is sulfuric acid, because then we would be adding a sulfate ion and testing for a sulfate ion, which would be stupid. On the second day of lessons, my teacher made me state 2 steps with acid. Okay, so what are we testing for here? We're adding hydrochloric acid to test something. It's generating something, a gas presumably, that we're testing with lime water. Well, we know that we use lime water to test for carbon dioxide gas. What gives off carbon dioxide gas when it reacts with an acid? Hopefully you remember a carbonate. So if we have a carbonate, we add dilute hydrochloric acid, and if a gas is produced, if it bubbles, then that bubbles through lime water, and we can test it with the lime water to check for carbon dioxide. And the test for a metal sulfate, have you already forgotten it? I bet several of you have. On the third day of lessons, my teacher made me state 3 halide colours. How do we test for the halides? Well, we add silver nitrate solution. If we get a white precipitate, that means that there was chloride present. If we get a cream precipitate, that means bromide was present. And if we get a yellow precipitate, that means that iodide was present. But again, there are things that could give a false positive, so we need to use acidified silver nitrate solution. Again, we would normally use nitric acid. The one thing we must not use is hydrochloric acid, because then we're adding a chloride, testing for a chloride. Of course, we are going to find a chloride. Can you remember the acid test? And can you remember the test for a metal sulfate? On the fourth day of lessons, my teacher made me state 4 tests for gases. These you've probably done even earlier, as early as year 7 here. Testing for oxygen, relights a glowing splint. Test for carbon dioxide is lime water. Test for hydrogen is a squeaky pop. The one you might not remember is the test for chlorine, is that it bleaches damp blue litmus paper. It'll first go red and then it will go white as it bleaches. What was 3? 3 halide colours. Can you remember the reagent? Can you remember the colours? What did we used to do for a carbonate? 2 steps with acid. And finally, a test for a metal sulfate. On the 5th day of lessons, my teacher made me state 5 burning splints. You only had to learn 5 flame test colours at GCSE. That is expanded up to about 12 at A level. But can you remember what these 5 were? Well, the lilac flame was potassium. The green flame was copper. The yellow or yellow-orange flame, that was sodium. The red-orange flame, that was calcium. And finally, the crimson flame, that was lithium. And yes, you do still need to know those. And yes, we're going to add those on top. 4, 3, 2, 1. Can you remember those reagents? And finally, on the 6th day of lessons, my teacher made me state 6 cation colours. 6 different cations that give a precipitate with sodium hydroxide solution. The dark green precipitate was an iron 2+. The rusty brown precipitate, iron 3+. The lovely blue precipitate, copper 2+. And then you had 3 that formed white precipitates with sodium hydroxide that you had to learn. And they were magnesium hydroxide, so the magnesium ion, and calcium, but also aluminium. And there was one extra test that you could do to tell the difference between those 3. What was that test? Well, the test was if you added excess sodium hydroxide, then the aluminium would redissolve. So you could distinguish the aluminium because the precipitate would redissolve if you added extra hydroxide. The magnesium and calcium wouldn't, but you can identify calcium from the flame test. So, do you remember your 5 burning splints, your 4 gas tests, your 3 halides, your test for carbonates, and your test for sulfates? Let's see. When a flame test is carried out on calcium iodide, the colour of the flame would be, well, which of those would it be? Calcium gives a yellow-red or an orangey flame, so the answer is A. Pale green, you might be thinking copper, but actually, as you will learn, barium also produces a green flame. Purple, well, if they mean lilac, then that's potassium. And crimson is going to be lithium. You should have been able to answer that from GCSE knowledge. A solid gives a red colour in a flame test, a red colour in a flame test. So it's not sodium, which is yellow-orange. It's not calcium, which is red-orange. It could be lithium and strontium. So from your GCSE knowledge, you've already narrowed it down to 2. The bit that you don't know yet is that we can test it with concentrated sulfuric acid. And if it produces steamy fumes but no other gases, that means it is a chloride. So the answer must be B, strontium chloride. This question is about iron 2 salts. Describe a chemical test and the result to show that sulfate ions are present. There you go, we've talked about this. It's straight from GCSE. Acidified barium chloride solution, and the result would be a white precipitate. If you already know this going into year 12, great. You've reduced your workload. But if you don't know your GCSE tests, you're going to have to learn those on top of all the A-level tests that we're going to throw at you. Presence of some compounds can be identified using a Bunsen burner flame. Flame test on a white powder gives a lilac flame. You should know that that is potassium. And dilute hydrochloric acid was added, bubbled, lime water turned cloudy. That tells us it's a carbonate. Great, but look, we're told the formula of the white powder. And from earlier lessons, you should know that potassium is K+, carbonate CO3 2-, and therefore you should be able to give the formula K2CO3. As well as the facts from C8, it is presumed that you remember many of the facts that were presented to you at other points in the course, and this comes from C1. So in C1 you had to learn the properties and the trends in the halogens. So give the physical states of chlorine and iodine at room temperature and pressure. So let's have a look. Well, chlorine, hopefully you remember, is a pale green gas at room temperature, while iodine is actually a grey solid. You might be thinking purple, that's the vapour, but actually chlorine is a gas, iodine is a grey solid. Predict the physical states of astatine under these conditions. Well, we got fluoride, fluorine, chlorine, bromine, iodine and astatine. Fluorine is a gas at room temperature, chlorine is a gas, bromine is a liquid, it's one of only two liquid elements at room temperature. Iodine is a solid, so we'd expect astatine to be a solid as well. Justify your answer. Well, as you go down, the molecules get bigger, so bigger molecules. So that means stronger intermolecular forces. And that idea comes from C7 if you did AQA, with the idea of fractional distillation. So lots of these different ideas that you saw out in very different topics at GCSE are actually merged together at A-level, and justifying your answer there requires possibly knowledge of C7 to explain that. Which of the following describes the appearance of iodine under the stated conditions? Well, solid. You know that iodine is a shiny grey solid, so that limits it to C or D already. You hopefully remember that when you dissolve iodine in water, you get a dark brown solution. You hopefully remember those experiments from C1. The thing that's extra sort of AS knowledge is that you can test for iodine by dissolving your solution in a hydrocarbon, and you will get a purple layer, so it must be C. What would be the experimental observations if chlorine gas was bubbled through potassium iodide solution followed by the addition of cyclohexane? You can answer this from GCSE knowledge actually. So chlorine gas and potassium iodide solution forms, and you should know this, potassium chloride solution and iodine. So it's a displacement reaction. As we've said above, iodine solution is brown, while chlorine and potassium iodide and potassium chloride are fairly colourless. So the solution would definitely turn brown. There's no white precipitate, there's no bubbles of gas, the solution would not remain colourless. So it would turn brown. We tell that from GCSE knowledge. We can confirm that by adding cyclohexane, which is a liquid hydrocarbon, and we would get a purple layer, as we saw above. Give the formula of a reagent that would produce a cream-coloured precipitate when added to an aqueous solution of magnesium bromide. Well, we should know this. The thing that we would add is silver nitrate solution, AgNO3. and that would give us a cream coloured precipitate with a bromide. And again, that's GCSE knowledge. Hopefully from the previous PowerPoints you remember that silver is Ag+, nitrate NO3-, if you weren't already sure of that formula. This is new. The identity of the anion can be confirmed by testing the solubility of the precipitate in ammonia solution. Which pair of responses helps to confirm the identity? Right, so the new knowledge, silver chloride, silver bromide, silver iodide, testing those with dilute ammonia and concentrated ammonia. The chloride would dissolve in both. The bromide does not dissolve in dilute ammonia, but does dissolve in concentrated ammonia. The silver iodide does not dissolve in either. So which pair of responses helps to confirm the identity of the anion? It's a bromide, so it would be insoluble in dilute ammonia, soluble in concentrated ammonia, B. And if you've taken that on board, you should have no problem with the next question. This question is about tests for halide ions. They can be identified by the addition of silver nitrate solution followed by dilute aqueous ammonia. State the observation you would make at each stage when silver nitrate solution is added to chloride ions followed by dilute aqueous ammonia. 2 marks. Justify whether concentrated aqueous ammonia could be used to confirm that silver chloride has been formed. Okay, pause the video and see if you can get all 3 marking points there. Okay, so the first thing that we would say is when you add silver nitrate solution, you would get, and it's a chloride, you would get a white precipitate. If we added dilute aqueous ammonia solution, the second marking point is for saying when you add NH3 dilute, that would redissolve. 2 marks there. Justify whether concentrated aqueous ammonia could be used to confirm that silver chloride has been formed. No. Why not? Because AgBr also dissolves in concentrated ammonia solution. So that wouldn't distinguish, that wouldn't conclusively prove it was silver chloride. The presence of some ions in compounds can be identified using a Bunsen burner flame. Some metal ions give characteristic colours in a flame test. Describe how to carry out a flame test on an unknown solid. Well, you would probably say dissolve solid in water, soak a splint in solution, put into a roaring Bunsen flame. We will introduce you to better methods at A level, but that would get you the marks. Which of the following ions does not give a red flame? If you were paying attention, you would realise it was barium, which actually gives a green flame. Calcium is orange-red. Lithium and strontium are deep red. Some anions can also be identified by heating in a Bunsen burner flame. A compound heated in the test tube in a Bunsen burner flame gave off a brown gas and caused a glowing splint to relight. Well, you should recognise that that means oxygen gas is being given off. You almost certainly won't recognise that. That means that nitrogen dioxide gas is being given off. And this is the test for nitrates, which you haven't done yet, but will be added to your repertoire. And again, if you're adding it to your repertoire, fine. If you're actually having to learn all of the GCSE material at the same time, it's going to be a lot more work. And finally, here's a question for you to have a think about. The labels on 4 colourless solutions had fallen off in storage. It was known that the solutions were hydrochloric acid, magnesium sulfate, potassium chloride, sodium carbonate. In order to identify each solution, a number of tests were carried out. A. Solutions can be sprayed into a flame to produce a flame colour identical to that seen in the more conventional method with a solid on nichrome wire. Which solution would give a lilac flame? You hopefully can all identify that as potassium, so potassium chloride. Which of the following diagrams best illustrates the electronic transitions which take place during a flame test? You don't know this, but essentially the heat promotes an electron up to what's called an excited state. It jumps up to a new shell or a new subshell, and as it drops back down, when it cools, the energy is released as a photon of light. So the answer is B. Which solution produces a white precipitate with acidified barium chloride solution? You should recognise that as the test for sulfates. So that would be B. 2 of the solutions produce the same result with the addition of dilute nitric acid followed by silver nitrate solution. State the observation with this test and the 2 solutions that give this result. You would see a white precipitate which 2 things would give that? Well, anything with chlorides, so A, hydrochloric acid, and C, potassium chloride. Finally, the hydrochloric acid and sodium carbonate solution react together. State an observation you would make and write the ionic equation for the reaction. State symbols are not required. So what you would see, as we know, carbonate and acid, you would see effervescence or fizzing. You would not see carbon dioxide. You don't see that. So do be careful when it says what would you see, not what do you infer from that. And finally the ionic equation. So we've got HCl aqueous plus Na2CO3 aqueous forming H2O liquid plus CO2 gas plus NaCl aqueous, 2 of those, and then that is balanced. So splitting that into ions, 2H plus aqueous plus 2Cl minus aqueous plus 2Na plus aqueous plus CO3 2 minus aqueous. They're all ionic, they're all aqueous, they all split up. Water does not, it's covalent. Carbon dioxide is not split up, it is covalent. But sodium chloride is also ionic and aqueous, so we can split that up into the ions. See previous presentations for help. Finally, chloride, spectator ions, sodium, spectator ions. So the overall ionic equation, 2 protons and a carbonate anion come together to give water and carbon dioxide gas. And that is the end of that presentation. The point of this, and it is a short one, but the point of this presentation is just to show you that if you don't know those facts from C8, you're going to have a lot more work next year. And that will be problematic if you're already struggling with the concepts, the more difficult concepts that are introduced. So use your time over the summer to make sure you know those tests, the 6 tests of C8 from the beginning of this presentation, so that you can answer those properly.